Have you ever held a magnet in your hand and felt it pull towards a metal object? It's a fascinating sensation, isn't it? It's like an invisible force is at work, drawing the metal closer and closer. This force is called magnetism, and it's what makes magnets so fascinating. But what exactly is magnetism? Magnets have the ability to attract certain metals like iron, nickel, and cobalt. These metals are known as ferromagnetic materials, but how do they do it? How do these small objects create such a powerful force? What's the secret behind this mysterious attraction? The answer lies in the atomic structure of these metals. Let's dive in and find out how magnets work. At the atomic level, magnets have regions called domains. We've all played with magnets, haven't we? These domains are like tiny magnets within the magnet. Maybe you've used them to stick pictures on the fridge, or to hold up important notes, or to pick up small metal objects. These everyday uses are just the tip of the iceberg. But have you ever stopped to think about what makes them work? It's a question that has intrigued scientists for centuries. It's all about a force called magnetism. This force is generated by the movement of electric charges. This force is invisible, but we can see its effects when a magnet pulls on certain metals. The alignment of the domains creates a magnetic field. Magnets have been a source of wonder and curiosity for centuries. Ancient civilizations used lodestones, naturally magnetized pieces of mineral magnetite. Even today, scientists are still learning new things about them. Research continues to uncover new properties and applications. So, get ready to explore the amazing world of magnets with me. We'll look at how they work and why they are so important. We'll uncover the science behind their powers, from the basics to the more complex theories, and discover how they impact our lives in countless ways. From simple fridge magnets to advanced medical equipment, magnets are everywhere. Get ready for an adventure into the world of magnetism. Together, we'll explore the unseen forces that shape our world. Our journey begins thousands of years ago, with the ancient Greeks, a civilization known for its remarkable contributions to philosophy, science, and the arts. Among their many discoveries, they found a naturally occurring magnetic rock called lodestone, which intrigued scholars and laypeople alike. This rock, made of a type of iron oxide, had a peculiar property. It could attract small pieces of iron, a phenomenon that seemed almost magical at the time. Imagine their surprise and curiosity when they first saw this. It must have seemed like the rock had a life of its own. The Greeks called this mysterious stone magnetite after the region where it was found, Magnesia, a place that would forever be linked to the study of magnetism. They soon discovered that lodestones could be used for navigation, noticing that a freely suspended lodestone always pointed in a particular direction, which we now know as north. This groundbreaking discovery paved the way for the development of the compass, a tool that revolutionized seafaring and exploration, allowing sailors to navigate the vast oceans with greater confidence. Over time, people learned to create their own magnets by rubbing pieces of iron against lodestone, a process that transferred the magnetic properties to the iron. These early magnets were not very strong, but they sparked even more curiosity about the nature of magnetism and its potential uses. Scientists and inventors continued to experiment with magnets, trying to understand their properties and find new ways to harness this mysterious force. From those early discoveries to the powerful magnets we have today, the journey of understanding magnetism has been long and fascinating, marked by numerous breakthroughs and innovations. And as we continue to learn more about this invisible force, its potential applications seem limitless. From medical devices to advanced technologies, magnets play a crucial role in our modern world. Every magnet creates an invisible area around it called a magnetic field. This field is a region where magnetic forces are exerted, and it extends in all directions from the magnet. This field is what allows magnets to interact with objects without even touching them. It's like an invisible hand that can push or pull on certain materials such as iron or steel. Think of it like an aura or a bubble that surrounds the magnet. This bubble is filled with magnetic energy that can influence other objects within its reach. We can't see magnetic fields with our eyes, but we can visualize them using iron filings. These tiny pieces of iron align themselves along the magnetic field lines, revealing the hidden structure of the field. If you sprinkle iron filings around a magnet, they will arrange themselves along the lines of the magnetic field. This creates a fascinating pattern that shows the direction and shape of the magnetic forces. This creates a visual representation of the invisible force emanating from the magnet. It's a simple yet powerful way to see the unseen world of magnetism. The shape and strength of a magnetic field depend on the shape and size of the magnet. Different magnets produce different field patterns, which can be observed using iron filings or other visualization techniques. For example, a bar magnet has a different magnetic field than a horseshoe magnet. The field lines of a bar magnet are straight and parallel, while those of a horseshoe magnet are curved and concentrated between the poles. The closer you are to a magnet, the stronger its magnetic field. This is because the magnetic forces are more concentrated near the magnet's surface. As you move further away, the field weakens, the magnetic forces become less intense, and the magnet's influence on objects diminishes. Understanding magnetic fields is key to understanding how magnets work. By studying these fields, we can learn how to harness the power of magnetism for various applications. They are the invisible force fields that allow magnets to attract and repel other magnets and magnetic materials. This fundamental property of magnets is what makes them so useful in everyday life and technology. Every magnet has two ends called poles, a north pole and a south pole. You can think of these poles as the strongest points of the magnet where the magnetic force is most concentrated. Here's the interesting part: opposite poles attract each other, while like poles repel. So if you bring the north pole of one magnet close to the south pole of another magnet, they will pull towards each other and stick together. However, if you bring two north poles or two south poles together, they will push each other away. This is the fundamental law of magnetism. Opposites attract and likes repel. This principle of attraction and repulsion is what allows us to use magnets in so many applications. For example, in electric motors, magnets are strategically placed to create rotational force. The attraction and repulsion between the poles of different magnets cause the motor to spin. Did you know that the Earth itself acts like a giant magnet? It's true. Our planet has a magnetic field that surrounds us, extending from deep within the Earth's core, far out into space. This magnetic field, called the magnetosphere, acts as a protective shield against harmful radiation from the sun. It deflects most of the charged particles from the solar wind, preventing them from reaching the Earth's surface. The Earth's magnetic field is generated by the movement of molten iron in the Earth's outer core. This swirling, conductive fluid creates electric currents, which in turn generate the magnetic field. Without the Earth's magnetic field, life as we know it would be impossible. It protects our atmosphere, our oceans, and all living things from the sun's harmful radiation. Magnets are everywhere. We use them in countless ways, from simple everyday objects to sophisticated technologies. Think about the refrigerator magnets that hold your shopping list, or the magnets that keep your cupboard doors closed. Magnets are essential components of many electronic devices. They're found in headphones, speakers, and computers. Without magnets, we wouldn't be able to enjoy music, watch movies, or even make phone calls. In the medical field, magnets play a vital role in magnetic resonance imaging, or MRI machines. MRI uses powerful magnets and radio waves to create detailed images of the inside of the body, allowing doctors to diagnose and treat a wide range of medical conditions. Magnets are also used in generators, which convert mechanical energy into electrical energy, and they're becoming increasingly important in renewable energy technologies, such as wind turbines, which use magnets to generate clean electricity. You don't need a fancy lab to explore the wonders of magnetism. You can conduct simple experiments at home using everyday objects and a few magnets. For example, you can test different materials to see which ones are attracted to a magnet. Gather a variety of objects such as a paperclip, a coin, a piece of wood, and a plastic button. Hold a magnet near each object and observe what happens. You can also explore the concept of magnetic poles by using two bar magnets. Mark the poles of each magnet with N for north and S for south. Bring the north pole of one magnet close to the south pole of the other magnet and observe the attraction. Then, bring two like poles together and observe the repulsion. These simple experiments can help you visualize magnetic fields, understand the laws of attraction and repulsion, and gain a deeper appreciation for the invisible forces at work all around us. We've covered a lot of ground in our exploration of magnets. Let's recap some of the key points we've learned. Magnets are objects that produce a magnetic field, an invisible area of force that surrounds them. Magnets attract certain metals, such as iron, nickel, and cobalt. Every magnet has two poles, a north pole and a south pole. Opposite poles attract, and like poles repel. The Earth itself acts like a giant magnet, with a magnetic field that protects us from harmful solar radiation. Magnets have countless practical applications in our everyday lives, from simple toys to sophisticated technologies. Understanding these fundamental concepts about magnets allows us to appreciate the science behind their amazing properties and the countless ways they impact our world. Our journey into the world of magnets doesn't end here. There's still so much more to explore and discover about this fascinating force. For example, scientists are constantly working to develop new and innovative ways to use magnets in fields like medicine, transportation, and energy production. If you're interested in learning more about magnets, there are many resources available online and in libraries. You can read books and articles, watch documentaries, or even visit science museums to learn more about the history, science, and applications of magnetism. So, keep exploring, keep experimenting, and keep asking questions. The world of science is full of wonders waiting to be discovered. Thanks for watching. Please don't forget to subscribe. I will see you in the next video. Keep exploring.